Bismillah Rahman Rahim. In this session, we will discuss Test Yourself from page 141 from the O-level physics book written by Tom Duncan and Heather Kennett and published by Hodder's Education. And here we have few questions. Number one is how would the size and brightness of the image formed by a pinhole camera change if the camera were made longer? So the camera size has changed, or its position has changed with reference to the object. So the image formed by a pinhole camera would change or would vary with the geometry of the source and the object. If we change the source position or the object position, or both source and object position, that the image form will vary, will change. So image formation will be different if we change the source or object or both. So this is very important. Question number one. Second, what changes would occur if the single pinhole in a camera were replaced by 4 pinholes close together? Instead of one pinhole, single pinhole, we replace this single pinhole with 4 pinholes and very close 4 pinholes. In that case, the ray will pass through each 4 pinholes, and umbra and penumbra gives a blurred shadow. So the shadow, a sharp shadow, will not be observed. Instead, a blurred shadow, a dark and a bright and a dark and a bright kind of shadow will form, and this is will be a different image. A different kind of shadow will be observed. Suppose a hole of 1 centimeter wide. 1 centimeter wide hole is used. A very small source of light called a point source gives a very sharp shadow, as we discussed in a previous video or previous session, which is equally dark all over. If a small point source is used, then we will obtain a very sharp shadow. The small hole in a card acts as a point source. So the point source gives a very sharp shadow with all penumbra and missing penumbra. So there will be no penumbra but all penumbra, as discussed this. We will give the image like this. For small point hole, we will get this kind of image. So this is very important. So, in a part 3, in question number 3, in figure 3.2, 3.218, this figure, the completely dark region on the screen is which one? On the screen, the complete dark region of the screen will be QR. When watching a distance firework displaying, do you see the cascade of light before or after hearing the associated bell? Explain your answer. When watching a distance firework display, do you see the cascade of lights before or after hearing the associated bell? Explain your answer. We always hear the bang after the flash, because the light appears before or earlier associated bang in a firework event, because the light speed is faster. So light will appear first and the bang or the sound will appear later on, because the speed of light is much faster or high as compared to the speed of sound. Question number 5. A ray of light strikes a plane mirror. A ray of light strikes a plane mirror. This is a plane mirror. Here we have this plane mirror at an angle of 60 degree. This is 60 degree incident angle. This is the normal, and this incident angle is 60 degree. This I1 is reflected from the mirror, and it is reflected from this mirror at this side and strikes a plane mirror. This is, and this reflected rays will strike on a plane mirror placed so that the angle between the mirrors is 45 degree. This mirror and this mirror, the angle is 45 degree. This is 45 degree is given here. The angle of reflection at the second mirror is in degree is one of the answer. So let's see how it will appear, because this is 60 degree, so this will again be a 60 degree. So this is 60 degree. The reflection, first reflection is 60 degree, and afterwards, since this is 45 degree and we have this normal, second normal on this second plane mirror, so this is 45 degree and this is 90 degree, so this will again be a 45 degree. So this normal with this plane mirror is a 45 degree. So since this is a 60 degree, so this angle, so this is, since this is 90 degree, and so in that case, if this is 45 degree and this is 90 degree, if we place this at a normal 2, so this will be appear with a 15 degree. Because of that 45 degree, this will additionally 15 degree. So this is 15 degree. So this normal gives this 15 degree. So the angle of incident on this mirror will be at 15 degree. So this is 15 degree, and this will be reflected with a 15 degree. So this angle, reflection of angle, will be 15 degree, and this total will be a 30 degree. So this 30 degree, and so this is 30 degree, because this was 60 degree, so this was 30 degree. So this 30 degree, 45 degree, so this is 75 degree. From here, this is 30 degree, this is 45 degree, this is total is 75 degree, so this is 105. So from the 05, we have this 90 degree. So on this side we have 15 degree, so this side will also be a 15 degree. So this will reflect, second reflection will be at 15 degree. So this answer 15 degree is correct. This is very, very important question. If we can change the angle of incidence, and we can reproduce at a different angle. So this kind of questions may be asked in a final examination of O level or IGCSE. This is very, very important, and this kind of problems have been discussed in this experimental setup. This experimental setup also demonstrates this kind of problem. So this is very important. So another image can be formed, or with variation of demonstration, this can be used. So this problem is important. This is very, very important problem. In a question number 6, in figure 3.219, at which the point A to D will the observer see the image in the plane mirror of the object. So we have this object is here, and there are number of possibilities. One is a correct one. So we see this, the object will be here and object will be here, and this two rays, incident rays, and that will be extrapolated at this point. So this at the image will be formed at point B. So here, if the object is here, the distance of that object from this plane mirror to the distance, and this two distance will be same, and the angle will be same like this. So object will be formed at point B. So object will be observed at B. So image will be observed. The image of this object will be observed at B. In figure 3.220 shows the image in a plane mirror of a clock. The correct time is this is 2:35. If we see this clock in a mirror, we will see this. So this image will be here, and this will be here. So it will be 9:25. The image of the clock will be 9:25. For 2:35, the image will be 9:25, and we can form different image from this. So this is 9:25 is the correct answer. So we can form different kind of images at different angles. Different kind of images can be formed. So this is very, very important. Question number 7. And in the next session,